Last time we discussed one question. Do you remember the question? What is it?
There was a sphere with center of mass here.
Not that one. Before the board, man, the long sum.
Yes.
Right. So that is one process to do that. Another process is like we have a person here. Now you have person here. This is the board. If you see the question, the length is 25 meter. The mass of the body is 50 kg. Mass of the body is 200 kg. Right? He is running with a 2 meter per second. No, not here. At this part, the speed is 2 meters per second. What is the speed of the boat? You need to find. Not only this is with respect to boat. Okay. Now you see velocity of the person, boy, like man. Man with respect to boat is 2 meters per second. Hence the velocity of the boat with respect to x is, with respect to ground is x. Right? Now velocity of the man with respect to ground will be what?
V.
Velocity of the man. Velocity of the man with respect to boat will be velocity of the man with respect to ground minus velocity of the boat with respect to boat. Now we want velocity of the man with respect to ground, that is equals to velocity of the man with respect to boat plus velocity of the boat with respect to ground. So this is 2 plus x. Right? But thing is, he is moving this side. The boat is moving this side. Right? This will be minus x. So here also we will be having minus x. So this will be 2 minus x. Now we will do the same formula. VCM equals to m1 v1 plus m2 v2 by m1 v1. M1 plus m2. So velocity of center of mass we know m1 v1 plus m2 v2 by m1 plus m2. Velocity of center of mass will be 0 because there is no external force at that time. Initially it is 0, actually it is 0. So velocity of center of mass also will be 0. So 0 equals to m1 v1 is what? V1 is this velocity of man with respect to ground. V2 is velocity of the boat with respect to ground. We know m1 equals to 50 kg, m2 equals to 200 kg. Right? So the values, m1 is what? 50 into 2 minus x plus 200 into minus 6 whole by m1 plus m2 is 250. So if you do here, 250 and come here it will be 0. So 50 into 200 minus 50x minus 200 equals to 0. So if you send that side, 250x will be equals to 100. So x will be 100 by 2. So that is 2 by 5. Right? But velocity of boat with respect to ground is what? Velocity of boat with respect to ground only is what? Right? That is minus. That means minus 2 by 5 minus. We got the same answer, right? So this looks simpler, right, compared to previous one. Previous one we found acceleration, relative displacement. So we can do like this also. This is example 5 you can see. Page numbers not matched. So example 5, if you can see, a block of mass M is placed on the top of which of man capital M, and the system is placed on a horizontal surface. The base length of the wedge is L, and all the surfaces are smooth. The displacement of the wedge by the time the block reaches the bottom of the wedge. So here the question is, you have a wedge like this, wedge of mass capital. There is a small mass is there. Now this mass generally will slide, right, because of gravitational force. It will be sliding down. Now, initially the center of mass will be somewhere over here. Okay. The weight will be acting downwards, right? So there will be no acceleration initially and finally of acceleration of center of mass. But this body is moving this side, right? This body is moving this side. That means this body having displacement this direction also, this direction also. That means this body having acceleration this side also, this side also. Now if you see the acceleration of center of mass, or if you observe center of mass, is there any force acting horizontal direction? Vertical direction, normal force is acting, weight also acting, both get balanced. So net force will be zero, so there will be no acceleration. Horizontal direction, is there any acceleration? So center of mass. Is there any force acting on center of mass in horizontal direction? No external force. Right. So it applies normal force, this also applies normal force, but that is internal force. Internal force cannot affect acceleration of center of mass. Right. So there will be no acceleration of center of mass if you consider horizontal direction. They said this distance is x. XL. L. This distance is L. Now this body, it is falling, it is moving down. As it is moving down, now this body has to move this side to keep the center of mass at the same position. Right? We are discussing about the horizontal center of mass, horizontal velocity or horizontal acceleration of center of mass, or position of center of mass along x-axis. So there is no force acting on x-axis. There is no force acting along x-axis on the center of mass. So there will be no acceleration of center of mass along x-axis. Now you see, when the body has come here, when this body displaced to here, what will be the displacement of small m?
Again question.
So when a body, this will be moving this side. Body will move from here to here. The body is moving from there to here. Now, what will be the displacement of this body along x-axis? This body, when a body is come from there to here. So that means what? Vertically travel this much distance, horizontally travel this much distance. That is what the displacement, right? When the displacement is from there to here, horizontal displacement is this much, vertical displacement is this much. Same case for this body also. When it travels from here to here, horizontal displacement is this, vertical displacement is this much, right? Now, if this body is at rest, this wedge is at rest, the displacement of the body is L. But that also will move, because to keep the center of mass at rest along x-axis, both should move, right? So initially the body is here, right? You just move this side. The body initially here, the small mass, later it has come here. For example, it has traveled distance x. So this will be L. No, this is L. So this will be how much? This x means this also x only, no? So this will be L minus x. So this is what the distance traveled by the small mass. Distance traveled by the capital mass is capital mass wedge. Capital mass in the sense wedge. Distance traveled by the wedge is x. Distance traveled by the small mass is L minus x. So this RCM will be what? RCM will be 0. There is no change in position of center of mass. So we know R1 equals to L minus x. R2 will be equals to x. Right? Now RCM equals to m1 x1 plus m2 x2 by m1 plus m2. M1 is m, x1 is L minus x, plus m2 is capital M, x2 will be x2 will be. See the displacement of this body this side, right? This body displaced this side, you know. This wedge is displaced in that side, so it will be minus x, right? Minus x, so it will be minus x by m plus it is 0. So m into L minus x plus m into x equals to 0. So ml minus mx equals to 0. We need to find x only, no? We will write m plus m into x equals to ml. So x will be what? ml by. So this is the distance traveled by the wedge. That's opposite to the displacement of x, right? But here, before I miss something, position of center of mass along y direction. That will change. Why it will change? Because this mass initially here, right? Because this mass is here initially. Now it has come down, but this mass is not moving up. To keep the center of mass at same position, one body being moving down means other body should rise up, move according to this. But it is not going up. So there will be some change in position of center of mass along y axis, but there will be no change in position along x axis, right? Next topic is shift in center of mass. Shift in center of mass. Shift in center of mass means, for example, we have uniform mass distribution. We have a square here. Okay. The center of mass will be here. If it is uniform mass distribution. Now what we have done, we have 4 parts. Remove this part. Right? Initially the center of mass here only. After removing that part, the center of mass will be here or it will change. The position of center of mass will change. That means the center of mass will be shifted. Not only in this case, for example, we have what we can say disk. Right. Disk of radius r. So if it is the center of mass will be at the center in case of uniform mass distribution. For example, you removed a small portion here, then center of mass will be shift down. Right? So how to find the shift in center of mass? That we'll see here. Shift in center of mass means if you remove some of the portion, some mass from the body, the center of mass position will be changed. How much is shifted? Shifted means the difference between or the distance between initial center of mass and final center of mass, right? So the square example we will take. You have a square of mass m and side a, right? The center of mass will be at the center. Now what you have done? Removed 1/4 of its mass of the which part is right, in top right corner. 1/4 of the mass removed. So here initially the center of mass is here. Now the center of mass will be somewhere over here, right? This is the initial center of mass. You consider this as C1. C1. This will be C2. Shift will be what? That is the shift, right? Shift equals to what? Difference between two centers, or distance between two centers. Distance between initial and final center of mass. Initial and final center of mass, right? Now what we will do? We will try to find center of mass of this. Initially center of mass will be here, right? How to find center of mass of this? I mean, how to find this distance? How would find it?
Taking two systems.
We will take two different systems. We consider this is one, this mass is there, right? We remove portion. We consider this as M1, this as M2. M2 as the center of mass at the center, right? When it is here, the center of mass will be here only. We consider this part is origin. We don't know this distance, but we know this distance. That distance means initially where it is. This is the portion, right? This is the center of mass of that part. This distance we know, right? What it will be? This is the square of side A. We didn't mention from anywhere. Total mass is m. Side A, it is a square. Right? Now, from here to here it will be A by 2. From here to here it is A by 2. From here to here it will be. From here to here it will be square root of a square by 4 plus a square by 4. So from here to here it will be this by 2, right? So that will see. So we draw the diagram and that one moment. C2 which is M1, which is M2?
Small boxes.
M1.
2.
This we consider this is C1, this is C2. Okay. We know this is A and this is A by 2. So this distance is what? For example, if it is this will be x2, right? This will be x1. So we know m2 will be, see this is a square, total mass is capital, then what will be the mass of this portion?
M minus M1.
Total mass is m. What will be the m1 then? It will be m by 4, right? M by 4 only, no? So m1 is what?
3M by 4.
M minus m by 4. That means 3m by 4. Right? We know x1 equals to x. X2 will be what? We don't know. So it will be a square by 4 plus a square by 4 whole by 2. That means 2 into a square by 4 by 2. That means a by 2 into root 2 by 2. So a by 2 root 2. Right? RCM is 0 anyhow. 0 here. So here it is. Okay. What we'll do, you consider this as D. Right. So when it is required, we'll replace with the A by root. You consider that is D and that it is required. So RCM will be what? We know RCM equals to M1 R1 plus M2 R2 by M1 plus M2. So you consider this is origin. This is our x-axis. You consider. Right? You can consider this is our x-axis. This is origin. So this will be M1 will be. R1 will be x. R2 will be d. X2 we consider as d. So RCM equals to 0. So M1 is M minus M1. That only. So the value will be there, that will substitute later. But M1 will be total mass minus removed mass. Plus M2.
Sir, R1.
R1 is x. Plus M2 is what?
Capital.
This is M2 actually. Removed mass is M2, no? Not M1. So this is M2 into R2 is D by M1 plus M2 is capital. Total mass. Right? So from here if you see, and here one of that will be negative, right? Which one will be negative? This is also it is positive, this will be negative. Which one?
Minus X.
This will be minus x. So here minus of m minus m2 into x equals to m2 into t. So we brought this other side equation, so negative sign will be not there. We need to find x or d. X only. X only we need to find, right? So x equals to m2 by d whole by m minus m2. Right? So x equals to what? M2 is what?
M by 4.
Removed mass. Removed mass only, no? Removed mass. Into d is what? Distance from center of mass. Distance from. So d by. This is remaining mass. Remaining mass. Everything is fine. So where d equals to what? Distance between C and C. C is what? Center of mass of second word. Center of mass or removed mass. right? So this is the formula, general formula. Now you can substitute the removed mass means what? M by 4. Remaining mass is what? 3m by 4. M1 is remaining mass, no? So if you substitute there, x1 will be equal to removed mass is m by 4 into d by 3m by 4. D value also you know. D value is what? A by 2 root 2. So 4 get cancelled, m1 get cancelled. A by 6 root 2. X1 equals to. Right. So that is how we will find shift in center of mass. So this is the general formula to find shift in center of mass. General formula to find. Now if you have any shape, like here we have square, you may have circle. Circle also we will do first you go. For example, circle is there. The circle of radius. Capital, right? Uniform mass distribution, uniformly distributed with respect to mass. The center of mass will be at the center. Now what happened? We consider the mass of radius r is removed at that certain part, right? From where distance this is, for example, you consider d from its center. Now you need to find shift in center of mass. Now you see if mass is removed, the center of mass will be shifted this side. Because it is on the radius only. It will be shifted this side. So we need to find shift in center. Shift in center of formula. Formula is what? Mass removed into d by mass remaining. Mass removed will be what? You consider the mass of this. Even if you consider the mass of this is capital M, we don't know what is the mass of this. See there, the mass you have taken 1/4 of the portion, so total mass is capital M means the removed portion is M by 4. But here we don't know what is the removed portion. We have to find removed portion mass. Generally, mass equals to what? Density into volume. Right? Density into volume. Volume will be what? Density into, this is the disk, right? This is the disk. Volume will be area into thickness. Area into thickness. So density, this for this density will be same. Right? And area we can find pi r square. Thickness is same. So this is the one way. Other way, this and this having same mass density, right? So if we take mass density, then the mass will be what? We take mass density is lambda, linear mass density is lambda. Then the mass of this will be lambda into area of this. The mass of this will be lambda into area of this, right? So what we will do? Consider here mass density sigma. Lambda for linear mass density, right? It is area, right? So sigma will write. So then mass of the removed will be sigma into area of removed portion. Area of removed portion will be what? Sigma into this pi r mass. Remaining mass will be what? Sigma into area of remaining portion, area of total mass minus area of this, right? Pi r square minus pi r square. Because total area is pi r square, capital R square, minus removed portion is small r square. So sigma into r square minus r square, right? Distance d is given as d. Sometimes it may given as r by 2, or it is given as 2r by 3. Like some distance will be given. So here it is given as d, we give us d only. So shift in center of mass, shift equals to what? Removed mass, sigma into pi r square into d by sigma into pi into r square minus r square. So sigma sigma pi get cancelled. It is r square d by r square minus r square. Right. So like this we will solve shift in mass, shift of center of mass, shift in center of mass question. Right. This is one of the topic. Other topic is in center of mass we have other topic like if you have extended mass of non-uniform distribution. For uniform mass distribution, we have center of mass. But for example, you can see the book. There is a table. That one. They are given for uniform rod of length L. It will be L by 2 from one of the end. Then uniform semicircular ring will be 2r by pi from the center. If it is semicircular disc, then 4r by 3 pi from the center. Right. Hemispherical shell of radius r, this will be r by 2. Solid hemisphere of radius r, then 3r by 8. Hollow cone of radius r is h by 3. Solid cone means 2h by 3 from the base. Both of them from the base. Isosceles triangular plane of which is that also h by 3. Right? So these are fixed. We can find this, or if you want to find, we can use integration method. Right? What is integration method means? According to this, generally you have n number of masses. How to find center of mass? M1 R1 plus M2 R2 plus M3 R2. That is the formula, right? For example, you have a mass like this, non-uniform distribution of mass. So here you have certain mass. You consider that is M1. Here you will take small portions. Like this is a small mass, 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 this is a small mass. Now to find the center of mass is what? M1 R1 plus M2 R2 plus M3 R3 whole by M1 plus M2. That means total mass. So integration, that is what we will do in integration, right? Integration is what? Integral M1, this M1 R1 plus M2 R2 plus M3 R3 and so on, Mn Rn. This can be written in integration, or you can write integration. So you consider there is a mass, a small mass Bm at a distance x, right? Then sum of this will be this. We can write as integral x dot Bm, right? Then RC will be what? This by total mass. So integral x dot dm by total mass. If you don't know total mass if you don't know, again integral x dot dm by integral d. Right? So this is 0 to L. Suppose the length is L. So this is the method to find center of mass of extended body. If you have a non-uniform mass distribution, or you have uniform mass distribution also, you have a uniform mass distribution also, but you don't know where the center of mass. Now we discussed few things, right? For cone, The center of mass will be for hollow, it will be at h by 3. For solid, it will be 2h by 3. How we found it? We found by using this method, right? So this is the method of integration to find center of mass, right? For example, you have a question. It is given. I'll read the question. The linear density of a rod of length L varies as lambda equals to kx square by L. So linear mass density varies as k equals to m equals to kx square by L. Mass density only varies. So mass density is not constant. That means what? Mass is not uniformly distributed. It is a rod. It is a rod, but here you have different mass, here you have different mass, here you have different mass, here you have different mass. Right? Linear mass density varies like this. In terms of x square. Where k is a constant, x is the distance of any point from the end. Find the distance of center of mass from the end at x equals to 0. From here you need to find center of mass, right? So consider this is the origin. From here you need to find center of mass. So what is the formula of center of mass? R equals to integral x dot dm by integral dm. So dm is what?
Small mass.
Here dm is what? We know lambda, right? We don't know. If you consider a small mass, here lambda will be kx square by L, but dm small mass will be what? This lambda into dx only. You take small length dx. Mass will be what? Linear mass density into length. Here the length will be what? Dx. Then dm will be what? Lambda into dx. Right? So we will do integral x into dm is lambda into dx by integral lambda into dx. Can we cancel these two? We cannot cancel. So lambda integral x into lambda is what? Kx square by L into dx by integral kx square by L into dx. So I will do that remaining portion here. So x is cm, right? Because it is on x axis. So xm will be equal to what? K by L is a constant, so I have taken off. So integral x cube by x cube into dx. Limits we didn't define, no? So we have to define from 0 to L. 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 0 to L, 0 to L. So you have 0 to L by, again k by L into integral x square dx 0 to L. So k by L cancel. X cube, x power 4 by 4, 0 to L by x cube by 0 to L. So x power 4 means L power 4 minus 0 power 4 by 4, L cube by minus 0 cube by 3. So that means L power 4 by 4 into 3 by L. So 3L by xm equals to 3L. So that is how you find center of mass. It's variable mass distribution. Variable mass distribution is there. So you find by using integration method. According to integration method, xcm is equals to what? Integral x dot dm by total mass. If you don't know total mass, cutoff will find by using integration only, right? So this is about center of mass. Now, most of the questions come from these topics only, either shift in center of mass or variable mass, or that one, man is standing in one, man will be standing at one end, he is moving to the other end, what will be the shift in center of mass, right? Based on motion of the center of mass, we will get, or moving, like two bodies are moving, what will be the speed of the center of mass? These kind of questions you will get most of the things we covered, right? So next we will start rotating motion.